Hello. My name is Sir Alpha, and I'm here today to do a question paper with you guys, and hope you benefit from it. And yeah, hope you benefit from it. Hope you learn a thing or two and something new. I would really love if every one of you guys learned something new. So we have this question paper in front of us. This is a custom-made question paper for one of my students, and yeah, I decided let us do this question paper together, and I'll be able to teach you a thing or two. So we're going to start with question number one, which says 4y squared is equals to 9. Solve the equation. So we have the equation 4y squared is equals to 9. And if you look at each, if you see it, each of these questions are past exam paper questions for ZIMSEC. So I usually do this with my students. Every time my students has a couple of topics that they are very comfortable in, I look for past examination papers and combine and look for those questions and then give them those questions, not custom-made questions, but real examination questions. So underneath each question you see the details. Like question number 1, it says November 2006 paper 1 question 3b. So now you can have the chance now to go into the past examination paper. Maybe if you have the past examination paper, then look into the past examination paper and check, oh, is this question really there? It will be really there because I would have done the research for you. And if there are some questions that you think, no, I've done this before, then you check the info that, oh, yes, I've done this before. Yes, I've done this before. So yeah, if there are situations whereby you think, oh, I might have done this before, then you realize, oh yeah, for sure I've done this before. You look at the info there, then you say, oh, I've done a question paper for 2006 November. So okay, so let's get back to the question. It says number 1, solve the equation 4y squared is equals to 9. So there are two ways, there are two methods that we can use to solve this equation. So we're going to start with method 1, then we're going to go to method 2. Okay, so what does method 1 go like? So we start with 4y squared is equals to 9, and then we take and then we take 9 and then we send it to the other side, to the left hand side. So it becomes 4y squared minus 9 is equals to 0. Okay, then we factorize. Now we want to factorize. So I say factorize is to make brackets. So to make these brackets is my simple version of saying to factorize. So we want to take this and we want to bring it into some brackets. So how do we do this? We use what we call the difference of two squares. Difference of two squares. So meaning that we have, for this to happen, we have to have a difference. That means a minus, we have to subtract, which is number 1, right? We have to have also two squares. So we can check if 4y squared is a squared, then we think, okay, let me think, how do I get 4y squared? I'll say 2y times 2y. Then 2y times 2y, then I can get 4y squared. Okay, fine. Then what about 9? let me think, how do I get 9? I get 9 from saying 3 times 3. And then we get 9. So now that we have realized that completing the square can happen, now I say 4y squared. Let me just write it down first. So I write 2y in brackets to the power 2 minus 3, we can put in brackets as well, to the power 2 is equals to 0. So now we are going to use factorizing using difference of two squares. So it becomes 2y minus 3 in brackets, open bracket, 2y plus 3 is equals to 0. So whenever we are, remember, whenever we are doing difference of two squares, we have to make one bracket with a positive and the other bracket with a negative. So as you can see, one bracket has positive and the other one has a negative, as you can see. So now, if it's like this, now we say either 2y minus 3 is equals to 0 or 2y plus 3 is equals to 0. And then let's deal with 2y minus 3 is equals to 0 first. So 2y minus 3 is equals to 0. We take minus 3, we send it to the other side. 2y is equals to 3. Then we divide both sides by 2 so that we can remain with y. So y is equals to 3 over 2. Let's go to the other side, to 3y plus 3, to 2y plus 3. So 2y plus 3 is equals to 0. 2y is equals to minus 3 because we took the positive 3 and then we send it to the other side. And then 2y is equals to negative 3. Then we divide both sides by 2. And then we get y is equals to minus 3 over 2. So now our answer will be y is equals to 3 over 2 or minus 3 over 2. Right. So that's the first method that we used. Now let's try with the second method. So method 2, we're gonna work it out like this. We're gonna say 4y squared is equals to 9. So in an equation, right? So I tend to think in this way. When it's an equation, then I'm told to find y. I have to think, okay, how can I make y the subject of the formula? It doesn't always work, but in scenarios like this, whereby we only have one piece where there is y, I can actually make y the subject of the formula. So in this scenario, I would say I want to make y the subject of formula. So I have to remove 4 and I remove the squared on top. So this is how I also teach when we're doing subject of the formula, that you have to identify the letter that you are trying to make the subject. And once you have identified, now you have to identify all the other elements that you have to eliminate or remove, so that that letter, which in this case y, can be alone and can be on its own. So I have 4 and I have to remove the squared. So now I'm thinking, which is easier to remove right now? Is it 4 or is it the square? So in most cases, the furthest element is the easiest to remove. So it's easiest to remove someone who is far away from you, like in terms of relationships, like someone who you knew from school is very much easier to disconnect or to remove from your life than, let's say, your relative, like your cousin or your uncle. You see, it's very hard to remove your uncle from your life because they are very too close to you. So in this case, we have to remove the 4. So we say 4y squared is equals to 9. We have to remove the 4. How do we remove the 4? We say divide 4 both sides. Then we divide 4 both sides. So we have y squared is equals to 9 over 4. And then, right, we are left with y squared is equals to 9 over 4. But we haven't reached y. We want to find y. So that means we have to remove the squared. So how do we remove the squared? We introduce a square root sign to both sides. Square root sign to both sides. And then we get y is equals to, now we think, square root of 9. Does 9 have a square root? Then we think, if we think really hard, yes, 9 does have a square root, which is 3. If we think of the square root of 4, does 4 have a square root? Yes, it does. It's 2. So now we would say y is equals to 3 over 2. If that is your answer, it's actually half correct, and half wrong. Why? Because it's not necessarily 3 over 2, but it's plus or minus 3 over 2. Plus or minus 3 over 2. So what does this mean? To those who don't really understand why did we use the positive and negative sign here, it's because whenever we apply a square root, we tend to get a certain value, which is plus or minus 3. Every time we get plus or minus 3. So this means that if we say plus 3 times plus 3, we get 9. So then the answer that you get when you apply the square root, if you multiply it by itself, you should get this number. So if you multiply this by itself, it should get the same number. So if let's say we did plus 3 times plus 3, we got 9, minus 3 times minus 3. So the negative times the negative, then we get positive 9 as well. So meaning every time you apply a square root, the answer would be plus or negative. That answer when you apply the square root. It's different in cases of cube root. It's different in cases of cube root, but when you are using a square root, it's always the same, plus or minus. Plus or minus. Okay, so what does this mean? So this means that our answer is plus or minus 3 over 2, right? If you have, but also if you have a question like, but when we say square root of 9, most of the time we say 3. Yes, there are cases whereby we tend to ignore the negative sign, or in more rare situations where we ignore the positive sign. So for example, if I'm looking for this what we call this the side of this square. Okay, so let's say I'm looking for the side of this square. We say side. So we say side times side. That's the area of a square. But we are told it's equal to 49 square centimeters. So side times side, we get side squared, which is 49 square centimeters, right? And then we want to look how big is one side. So we say s squared is equal to 49, apply square root both sides, then s is equal to 7, plus or minus 7 initially at first, but we get to 7. Then what happened to the negative sign, you might ask? We ignored the negative sign. Why? Because when we're dealing with distance, we don't have a negative sign. No negative sign. When we're dealing with distance, no negative sign. So in most cases, you wouldn't even include this, what we call this step. So most of the time you just jump from here to here, then you become s is equals to 7. But actually it is true, but not in every case whereby your answer would be plus 7. So it depends. So that's where you have to understand the type of question that you have. So coming back, we got our answer y is equal to plus or minus 3, which is the same thing as here. Y is equal to 3 over 2 or minus 3 over 2, which is the same thing. Okay, number 2. Now we're going to do number 2. Number 2 says solve the simultaneous inequalities. So we have 2x minus 6 is less than 5x plus 3 less than or equal to 3x plus 11. Okay, so what we're going to do whenever we have a simultaneous inequality, usually we tend to group. So we usually group like this. This is more of the easiest way to do the stuff. So under the black bubble, we're going to take 2x minus 6 is less than 5x plus 3. So in inequalities is more like an equation, but we just replace the equal sign with a less than sign or a greater than sign or greater than or equal to or less than or equal to sign. But it's more or less the same. So whatever we do in equations to find our x is the same thing that we do here. So 2x minus 6 is less than 5x plus 3. So what we do, we group like terms. So I'm going to decide to bring all the x's to my left hand side. So 2x minus 5x is less than, then I'm going to send minus 6 to the other side. So it's going to be 3 plus 6. Okay, 2x minus 5x, we get minus 3x is less than 3 plus 6, which is 9. And then to remove, for me to be left with x, I have to divide both sides by negative 3. So once I divide both sides by negative 3, x becomes greater than negative 3. So I'm not sure if you have noticed this, but look at the sign. The sign has changed direction. You might be thinking, why did it change direction? Does it always change direction? No, it doesn't always change direction, but it changes once we divide by a negative number. Okay, so this is my way of writing negative, short way of writing negative. So then the minus sign, and then I write VE. So negative. If I want to write positive, I'll put it like this. So whenever we divide by a negative number, the direction of the sign changes. So we have our first piece, which is x is greater than negative 3. Now let's go and deal with the red bubble. So we're going to take 5x plus 3, which is less than or equal to 3x plus 11. Then we say 5x minus 3, x is less than or equal to 11 minus 3. So I grouped like terms once again, took all the terms that have x, put it to the left hand side, took all the constants, put them to the right hand side. So 5x minus 3x, we get 2x, which is less than or equal to 11 minus 3, we get 8. And then we divide both sides by 2, so that we are left with x. So x is less than or equal to 4. So now our answer, the way we write our answer, it's either we write x is greater than minus 3 or x is less than or equal to 4, right? Let me double check. Yes. We could write it like this, but if you want to be fancy, what you usually do, we put x in the middle, right? We put x in the middle, and then we take the biggest number, we put it to the right, we take the smallest number, we put it to the left, and then now we look at now we insert the what you call the signs. Now we insert the sign. So now we are looking here, x is less than or equal to 4. Okay, x, then we write is less than or equal to 4. So if it's the same, like same setup, like x is on my left, then 4 is on the right, you just take the sign as it is. But if it was opposite, like swapped, then you have to also swap the sign. Okay, so let's check this. X, or here it's minus 3, then we have minus 3, then x. Oh, okay, it's fine. So that means because x and minus 3 have swapped, we also have to change the direction of the sign. So it becomes like this. So it ends up becoming, let me write it clean. Minus 3 is less than x, which is also less than or equal to minus 4. Then we are done. Item 2 states, write down the least possible value of x. Least possible value of x, least possible value. So now we're thinking, okay, we can draw another line here. We can draw another line, and then we write from minus 3 to 4. So greater than or equal to or less than or equal to, we use a shaded bubble, a shaded circle. Then less than or greater than, we use an unshaded circle. Then we join. So now we are thinking of the numbers that are in between. So we have -2, -1, 0, 1, 2, 3. Then we get to 4. Now we're thinking of the least possible number. So I'm looking at 4, no, 3, no, 2, no, 1, no, 0, no, -1, no, -2, then -3. But it can't be -3 because -3 is not shaded and it's not included. If I use a red pen, it's not included. There was supposed to be a sign say or equal to for us to include the -3. But since there's no or equal sign, I mean, that means we have to go to the next number that's in front of -3, which is -2. So that means our least possible value is -2. So x is equals to -2. For number 3, it says for the numbers 10, 2, 9, 3, 9, 5. Find the mode, right? Find the mode. So when we talk of the mode, we're talking about the most repeated value or input, let's say. The most repeated value or input. So usually many times this could be a number, this could be a name, depending on what type of statistics question that we have. So now we have to think, okay, how many times we have to count each time? So 10, how many times has 10 appeared? Once. Okay. How many times has 2 appeared? Twice. I mean once. Sorry. How many times has 9 appeared? Now we think, oh, here's 9, here's 9. So it has appeared twice. How many times has 3 appeared? Once. How many times has 5 appeared? Once. So we skip the other 9 because we already counted it. So the one with the most appearances is 9. So we write our mode is equals to 9. B states find the median. So when we're dealing with median meaning the middle, right? The middle. So first of all, we have to rearrange from minimum to highest or highest to lowest. Lowest to highest or highest to lowest. I usually do from lowest to highest because it's natural for me, but anything anyway is good as well. So 2 is the lowest number. Then we go to 3. Then we go to 2, 3, 5. We go to 5. Then we go to 9. Then we write the other 9. And then we go to 10. Okay. So the easiest method that I encourage almost everyone to do is to cancel out the numbers. So in this case, I'm canceling 10 and 2. Right, you cancel in pairs. So you cancel in pairs. So 10 and 2, 3 and 9, right? And then you are supposed to be left with one number in the middle, right? So I'm going to give a separate example. So let's say I remove 1 9. So it's 2, 3, 5, 9 and 10. So usually it should look like this. You cancel 10 and 2, cancel 3 and 9, then you should be left with a number in between. So this becomes your median. So this automatically becomes your median. But now in this case, if we cancel these 2, we are left with nothing in the middle. That means we don't cancel them, but what we do is we find the number that's in between these 2. So now you might be asking, okay, how do I do that? We just say 5 plus 9. What does 5 plus 9 give us? 14, and we divide by 2. So you add the numbers, then divide by 2. So 14 divided by 2, we get 7. So 7 becomes our median. So to recap here, we said we arrange from lowest to highest or highest to lowest. Then we cancel in pairs from the outmost numbers to the going inwards. And then if we have a scenario whereby when we cancel, then we're left with 1 in the middle, then that becomes our median. But in a scenario whereby we are left with 2 in the middle instead of 1, we add them, we add the numbers together, then divide by 2. Then the answer that we get, which in this case is 7, becomes our median. Okay, 3C. 3C, find the mean. So when we find the mean, we add all the numbers. And then we divide by the number of numbers that we have. So in this case, we're going to say 10 plus 2 plus 9 plus 3 plus 9 plus 5 over how many? 1, 2, 3, 4, 5, 6 divided by 6. So now, since this is a paper 1 question, we are not allowed to use a calculator. So I would say 10 plus 2, we get 12, plus 9, I get 21, plus 3, I get 24, plus 9, I get 33, plus 5, I get 38. 38 divided by 6, what do we get? 6 into 6, 1, 6 into 38, we get 6, 36, remainder 2. Remainder 2, I'm thinking to make it a decimal fraction or a mixed fraction. So I'm thinking really hard about this. Then I'm going to decide, let me change it to a mixed fraction, because if you keep on dividing, you keep on dividing. So 6 and 2 over 6, then we reduce here, then we get 6 and 1/3. Yeah, hope this makes sense. Okay, we're now doing question number 4, which says the universal set is equals to 75, 76, 77, 78, 79, 8. M and R are subsets of the universal set. M is equals to even numbers. R is equals to multiples of 4. A item 1 lists the elements of set M. Okay, so we have to list the elements of set M. So let us first show the universal set. So we have 75, 76, 77, 78, 79, then 8. Okay, so we have that list as our universal set. Then we were told M has a list of even numbers from our universal set. So we have to think now, is 75 an even number? I bet every one of us knows what an even number is, but if there's no one who doesn't or forgot what an even number is, an even number is a number that when you divide by 2, you do not get a remainder. So for example, 2 divided by 2, so 2 into 2, we get 1, remainder 0. But it's different from an odd number like 3. 3 divided by 2, we get 1, remainder 1. So if you divide by 2 and you don't get a remainder, that means it's an even number. So now we think, okay, 75, is it an even or is it an even number? No. 76, is it an even number? Yes. So we write down 76. 77, is it an even number? No. 78, is it an even number? Yes. We write 78. 79, is it an even number? No. 80, is it an even number? Yes. Then we write this. Okay. So we have listed, and yeah, we've listed. Yeah. Item 2, item 2 says list the elements of set R. So set R, they told us that set R is multiples of 4. So multiples of 4, luckily, multiples of 4 are also even numbers. And also, if you are a multiple of 4, if you divide, if you are a multiple of 4 and that number is divided by 4, we should not get a remainder, so no remainders. So that means in this scenario, we are taking our even numbers that we have found, right? Because multiples of 4 are all also even, and that's all the even numbers that are in our universal set. So we take them, and then we divide each and every one of them by 4 and see if there's a remainder or not. So 4 into 4, 1. 4 into 7, we get 1, remainder 3. 4 into 36, we get 9. So it becomes 19, remainder 0. So that's a multiple of 4. Let's go 78. 78 divided by 4. 4 into 4, 1. 4 into 7, 1, remainder 3. 4 into 38, 9, remainder 2. So 78 is not. Then we go to the last one. 80 divided by 4. 4 into 4, 1. 8 into 4 into 8, 2. 4 into 0, 0. Remainder 0. So we have 2, 76 and 80. So now let's write it down. Let me write it here. R is equals to 76 and 80. So these are our answers. Let's go to B. Part B. It says find the number of elements in M complement union R. Okay, this looks a bit tricky. But I always tell my students that every time when you see something like this, take it step by step. So first, we want to deal with this guy. We want to deal with M complement. So step by step. So usually I would first list the elements of M first, which is 76, 78, and 80, right? And then when it says complement now I'm looking complement, that means everyone else that's in the universal set but not in M. So now I look at the universal set, then I think, okay, what other elements are not in M? Then I see 75, I see 77, I see 79. So I go back, then write 75, 77, and 79. Then I write them down. Okay, that's cool. Now I have to have R. Let me write R down. We said R is 76 and 80. So these are the multiples of 4. And then we have to have union now. M complement union R. So union, that means everyone we are joining together. Everyone we're joining together. Joining everyone everyone that's in M complement joins with everyone that's in R. So now it becomes 75, 76, 75, 76, 77, 79, because there's no 78, then 80. And then now, last but not least, we have to now count. So the number of elements in this is 1, 2, 3, 4, 5. So our answer is 5. Number five is a topic in variation. Yo, I love variation. Variation, I love. It's one of my favorite topics. So it says, given that v varies inversely as the square of t, right? As the square of t. Item A says, express v in terms of t and a constant k. Okay, so it shows that v varies inversely as the square of t, as the square of t. Square, not square root. They said square. A lot of people make that mistake. When they think of square root, they think of square, and when they think of square, they think of square root. So it said the square, not the square root of t. So if you know your inverse variation, you know that we do it like this. So in item A, it says express v in terms of t and a constant k. So remember, when they say v in terms of t and a constant k, that means we have to make an equation that has v, t, and k. It's different in a scenario whereby they tell you express v in terms of t and they didn't include k. It's kind of different, because now you have, if it's in a scenario whereby say v in terms of k, in terms of t, I mean, in terms of t, that will mean that you have to first find k, the constant, and replace the constant. Then becomes v is equal to maybe 2t, right? Or 2 over t squared in a scenario like this. So what do? We remove the sign of proportionality, this sign. We replace it with an equal sign. And then once we replace the sign of proportionality with an equal sign, we introduce k. So if k times 1 over t squared, which if we simplify, will give us k over t squared. So if you get this, this is the correct answer. So that's A. Let's see what B has in store. B item 1 says, find the value of k given that v is equals to 25 and t is equals to 2. So now we're going to use our equation that we formed, k t squared. Now we're going to replace the value v and t with the values that were given. So 25 is equals to k over 2 squared. And now we have to make k the sum of the formula. What I usually do, I would say, because I want to remove the fractions, I'm going to use cross multiplication. So 25 times 2 squared is equals to k times 1. So 25 times 2 squared, which is 4, is equals to k times 1, which is k. 25 times 4, 100. So that means k is equals to 100. And then we are done. K is equals to 100. Item 2. find the values of t when v is equals to 1/4. So now we take our equation, v is equals to k t squared, right? And then we are replacing k with 100. So we have a new equation like this. V is equals to 100 over t squared. And then we replace v with 1/4. So 1 over 4 is equals to 100 over t squared. Okay, so here I'm also going to use cross multiplication here. So t squared times 1 is equals to 100 times 4. So t squared times 1, we get t squared, which is equals to 100 times 4, 400. Okay, now we're thinking, okay, the square root of t squared is equals to the square root of 400. Then you're thinking, okay, what is the square root of 400? I don't know the square root of 400, right? The square root of 400 is 20, right? 20 times 20, we get 400. But let's say you're in those type of scenarios whereby this is paper 1. If you check, it says November 2006, paper 1, question 23. So this is a paper 1 question. You don't have a calculator and you don't know what the square root is. So in this, I'll show you how to find the square root if you are stuck in such a scenario. So for example, we have 400. We have to find the square root of 400. So what I do, I take 400 and then I divide by the smallest number that can get into 400. That's not 1. So 2 can get into 400. So 2, and then I'll be dividing going downwards. So 2 into 4, we get 2. 2 into 0, 0, and 0. Divide also 2. That's the smallest number that you can get into 200. So 2 into 2, we get 1. 2 into 0, 0. 2 into 100, we get 50. 2 into 50, we get 25. And now we reach here. 2 can't get into 25. Okay, maybe 3. 3 can't get into 25. 4 can't get, but 5 can get into 25. So we divide by 5. So 5 into 25, we get 5. Then we divide by again by 5. Then we get 1. Once you have reached 1, that's where you stop. And now you list 400 as a product of its prime factors. Now we are thinking of highest common factor and lowest common multiple. It's giving me that vibe. It's giving that vibe. Highest common factor and lowest common multiple. So we say 2 times 2 times 2 times 2 times 5 times 5. So we say 2 times 2 times 2 times 2 times 5 times 5. Okay, so now what we do, we group into pairs. So make sure, because we are dealing with square root, we have to put them into pairs. So we're putting this into pairs, this into pairs, and this into pairs. So it becomes 2 squared times 2 squared times 5 squared. Then if it's like this, now we can introduce the square root. So we introduce square root to both sides. Or let me introduce to each and every one of them. So now here we leave it just the square root of 400, since that's what we are looking for. The square root of 2 squared, if you know your indices very well, if you know your laws of indices very well, you know that the square root and squared cancel each other. So we are left with 2. We are left with 2 here, then we are left with 5. So now 2 times 2, which is 4 times 5, it will give us 20. And that's the long way, but it really helps. It really helps. This way, especially if you are not able to remember a lot of square roots of numbers, you can use this method to find your answer. So going back to where we started, t is equal to 20. Okay, we are doing number 6 now, which says p varies directly as the cube of r. Given that p is equals to 2 and r is equals to 4, find the formula connecting in p and r. So since we are doing variation, right, we have to understand what the question requires. So it says that we should find the formula connecting p and r. Notice that they never said k. If you know variation, we always have a constant. So since they haven't said find the formula connecting p, k, and r, they just said p and r, that means we have to find the formula. We have to find the value of k and then replace k in the original formula that would have created. So what does that look like? So we said number 6, right? And then it says p varies directly as the cube of r. So p varies directly as the cube of r. So it's like this. Then to remove the sign of proportionality, we introduce an equal sign, but we also introduce k. So p is equal to k r cube. Okay, so what values were we given? Given that p is equals to 2 and r is equals to 4. Okay, so we're given that p is equals to 2. So we put 2 where the p is, and we put 4 where r is. So k 4 to the power 3. So 2 is equals to k times, what is 4 times 4? 16 times 4. 64. So now 2 is equals to 64k. Now we have to find k. Divide both sides by 64. Then 1 over 32. So now k is equals to 1 over 32. And we have to replace k. So since we are now substituting k in this formula, it will look like this. Let me go at the bottom. It says p is equals to k r cubed. So it becomes p is equals to 1 over 32 r cubed. Then this will be our answer. So note, yeah, this is our answer. We have formed an equation with p and r. So we are done. We're done. Let's go to part B. Part B says find the value of p when r is equals to 8. So what we do is we take our previous answer, the formula, right? We take the formula, which is p is equals to 1 over 32 r cubed, and then we use this formula. But I've seen a lot of my students many times, they would start working from the top. So they will go like from the top. They'll start from here, then start trying to work again everything down. Yeah, that's what I see a lot of them do. But in variation, that's the good thing about variation, is that you just take the formula that you have done correctly, especially if you have done it correctly. There's no need to worry about anything. You just replace it. You just place it and then substitute your values. So in this scenario, we're looking for p, so p is equals to 1 over 32. What's r? What did they say? R is equals to 8, so we say 8 cubed. This is a paper 1 question, so we don't have a calculator. We cannot use a calculator. So we say times 8 times 8 times 8. I'm thinking, can 8 get into 32? Yes, 8 can get into 32. So I'm going to divide 8 there. Cancel 8 here, 4. Right. Then 4 can get into 8 twice. So 2 times 8, we get 16. So p is equals to 16. Yeah, that's our answer. For number 7 says the following entries show the number of bicycles sold per day in 9 days. So we're given 9 days and we're given the number of bicycles that were sold each day. 6, 10, 12, 9, 14, 10, 15, 10, 12. So we were given those days. And then we were told find the mode, right? Find the mode. So we're looking for the number which appears the most. So let's write our values down. So 6, how many times does 6 appear? Once. How many times does 10 appear? 3 times. How many times does 12 appear? Twice. How many times does 9 appear? I think once. 1 times 14 appears once. 10 we already done. 15 once. 10 we already did. 12 we already did. So the one with the most is 10. So our mode is 10. Median. For median, we arrange these numbers in order from lowest to biggest, or from biggest to lowest. I usually do from lowest to biggest. So 6, 9, 6, 9, 10, 10, another 10, 12, 12, 14 and 15. 14, 15. So let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so they are. And then what I usually do is that we cancel out. Once we are done this, the easiest way, we just cancel out the outer numbers in pairs. So we cancel these two at the same time, cancel these two at the same time, cancel these two at the same time, cancel these two at the same time. And then if we end up like in this situation with one number in the middle, then that is our median. So our median is 10. If we have a scenario whereby we end up with two numbers in the middle, since we are not allowed to have, we have to have at least one or two numbers. We cannot have zero numbers in between. But if we have a scenario where there are two numbers in the middle, you add the numbers in average. You just add the numbers, divide by 2, then the answer that you get is the median. But in this case, since we are left with one number in the middle, that number is our median. C says the next entry, find the next entry if the new mean on the 10th day is 12. Find the next entry if the new mean on the 10th day is 12. Okay. So we look at our list: 6, 10, 12, 9, 14, 10, 15, 10, and 12. And then we have a new entry, like what they said. We don't know that entry, so we're going to introduce x. And then they say the mean, that means like the average. Mean means average. So the mean of these 10 days where bicycles were sold is 12. So we're saying that if we add all of this and divide by 10, the answer that we should get is equals to 12. So we make an equation out of that. So we say 6 plus 10 plus 12 plus 9 plus 14 plus 10 plus 15 plus 10 plus 12 plus x, don't forget x, divided by 10 days or 10 input is equals to 12. So now we have this big equation. So I'm going to simplify it a bit. So I'm going to say 6 plus 10, I'm going to get 16. 16 plus 12, we get 28. 28 plus 9, we get 37. 37 plus 14, we should get 51. 51 plus 10, we get 61. 61 plus 61 plus 15, we get 76. 76 plus 10, we get 86. 86 plus 12, we get 98. 98 plus x over 10 is equals to 12. Okay, so now we say over 1, cross multiply, we get 120 that side. 98 plus x is equals to 12 times 10. These ones times 1, yeah. So we still get 98 plus x is equals to 120. 120. Then we say x is equals to 120 minus 98. And then what do we get? We should get 22. So the new entry should be 22. Hope this makes sense. Okay, now we have number 8. Number 8 says the temperature readings in degrees Celsius at noon over a period of 6 days where 30, 29, X, 31, 30, and 32. The mean temperature for the 6 days where 30 was 30.5 degrees Celsius. Calculate the value of X. Okay, so we have the different readings for those 6 days, and then we showed the mean temperature for those 6 days is 30.5. So meaning that if we take those values and then we add them up, so 1, 2, 3, 4, 5, 6, right? So we have all 6 of them divided by 6. It should give us 30.5. 30.5. So now I can simplify. So 30 plus 29, 59, plus X, plus 31 plus 30, which is 61, plus 32, 93. 93 is equals to 30.5. This one is over 6. Here I can cross multiply so that I can remove the fractions. So 1 times all of this, 59 plus X plus 93 is equals to 6 times 30.5. 59 plus X plus 93 is equals to 6 times 30.5. So 30.5 times 6, since this is a paper 1 question. So 6 times 5, 0. Then we carry 3. 6 times 0, get 3. 6 times 0 is 0 plus 3 is 3. 6 times 3 is 18. So we get 183. So 183 here. Then we say X is equals to 183 minus 59 minus 93. X is equals to 183 minus 59, or I could say, or I could add these two together. Let me just do that. 59 plus 93, get 2, carry 1, 6 plus 9, get 15. So 183 minus 152, X is equals to what do we get here? 5 minus 3 minus 5 minus 2, 3, 8 minus 5, 3. So we get 33. What's 33? 33 degrees Celsius. 3 marks. 3 marks, yeah. Done and dusted. Number 9, last but not least, simultaneous equations. Simultaneous equations, yo, they're so cool. Okay, so it says solve the simultaneous equations. 2x plus 2y is equals to 15. And then say 0, 3x minus 0, 2y is equals to 3. Okay, so if you notice something, this first equation has whole numbers throughout. They have whole numbers or integers. So that's what we want. We always want it to be like this. But if you look at the second equation here, we have decimal fractions. So we have to do something about those decimal fractions. So there's a way that we could do this. There are two ways. We could either multiply the second equation, I mean, by 10, because this is 0, 3. So the comma is going to move for everyone. So it's going to move. So here's a comma. It's going to move, and then it's going to become 30. Or we could change these numbers into fractions. So 0, 3 becomes 3 over 10. Then 0, 2 becomes 2 over 10. Then 3 becomes 3 over 1. And then we multiply everyone by 10, which is kind of the same thing, but it's different in terms of one way you change it to become a fraction, and the other way you just let it be a decimal fraction. Okay, so I'm going to choose multiplying by 10. So I'm going to take 0, 3x minus 0, 2 y is equals to 3. Then I'm going to say times 10. So meaning everything in this equation is multiplied by 10. So 0, 3x times 10, we get 3x, minus 0, 2y times 10, we get 2y, is equals to 3 times 10, which is 30. Okay, so 3x minus 2y is equals to 30. Now we have the perfect equation that we want. We wanted all of the numbers, all the coefficients and the constant to be whole numbers or integers, and that's what we got. So we're going to write this as equation 2. Going to define this as equation 2. Then I'm going to go at the top. Then I'm going to define this as equation 1. So let me write them nicely. 2x plus 2y is equals to 15. Equation 1. 3x minus 2y is equals to 30. Equation 2. Okay, so we have this scenario. The first thing that's catching my eye is this. This is the first thing that's catching my eye. So if you know how to deal with simultaneous equations, you would know that there are two main ways that we deal with simultaneous equations. So the main ways are dealing it with elimination. So we use elimination, or we use substitution. So here, when I see those two, they have the same coefficient. Even though they have different signs, it's still fine. As long as they have the same number, the same digit as the coefficient, that's all we want. Once we have that, we can use elimination. So we use elimination, the method of elimination, to eliminate y, and then we will remain with x. Okay, so how does that look like? So I'm going to write here equation 1 minus equation 2, right? Not equation 1 minus equation, actually equation 1 plus equation 2. Sorry for that. Plus, why am I adding? I'm seeing that these two have different signs. So when they have different signs, you add so that they can cancel out each other. If they have the same sign, that means you have to subtract so that they can cancel each other and produce a 0. So now it becomes 2x plus 3x, what do we get? 5x. 2y plus minus 2y, we get 0. 15 plus 30, we get 45. Then we divide both sides by 5 so that we can be left with x. We get 9. So x is equals to 9. So since we found x, let's find y. So how do we do that? I'm going to choose any. So you choose any equation. I'm going to choose equation 1. I'm going to choose equation 1. And then you substitute the value that you have found. So you usually do this once you have found one variable. So in this case, since we found x, we can substitute x. So you can say substitute x. So sub, short for substitute, x into equation 1. So that means it will look 2, open bracket, 9 plus 2y is equals to 15. Two times 9, we get 18. 2 times 9, we get 18 plus 2y is equals to 15. 18 moves to this side, so we're left with 2y is equals to 15 minus 18. y is equals to 15 minus 18, we get negative 3. Negative 3 divided by 2, get y is equals to minus 3 over 2. So x is equals to 9 and y is equals to minus 3 over 2. So just to test out if what we are saying is correct, we tend to substitute our values. So since the first equation was this, so we are already done. This is what we are doing just to make sure that our answers are correct, so that we don't just math has this tricky way that the way that you'll be working would seem so perfect that you would think that, no, there's no way that I'm wrong, but actually there's a tiny detail that we would have missed. So if you have ways whereby you can just recheck if your answer is correct or apply to see if your answer is correct, those methods are very, very good. So what I'm going to do, I'm going to substitute x and y into this side, and then when I simplify, it should give me 15. So 2 times 9, right, plus 2 times minus 3 over 2. So 2 times 9, we get 18 plus 2 times minus 3 over 2. This cancels each other. 18 plus minus 3, which is 18 minus 3, and then I get 15. Okay, the first equation is correct. So long, so good. Now we have to test the second equation so that we can be 100% sure. So 0, 3 x minus 0, 2y is equals to 3. So same thing, 0, 3 times 9 minus 0, 2 times minus 3 over 2. Okay, so we're going to do like this. We're going to change these decimals into fractions. So 0, 3 becomes 3 over 10 times 9 minus 2 over 10 times minus 3 over 2. Okay, so 3 times 9, we get 27 over 10 minus, here I'm going to cancel this 2 and this 2, then I'm going to get minus 3 over 10, and then 27 over 10. So we combine, since they have they already have the same denominator, we can combine these two. So 10 into 10, 1 times 27, 27. Then we write the negative. 10 into 10, 1 times minus 3, minus 3. So 27 minus 3, which is 27 plus 3, which is equals to 30, divided by 10, which is equals to 3. And then that's where we know, oh, we are actually 100% correct, because here it says is equals to 3. So that's how you do it. That's how you do with simultaneous equations, how you check if your answer is correct. And if you are able to do this with simultaneous equations, you would have 3 marks, because in ZIMSEC they love to give us simultaneous equations. They love to give us simultaneous equations. But yeah, that's the way to go.